Okay, class, we are ready for Chapter 9 4B, which is the surface area of cylinders. And I think you'll probably find that this is a little easier to grasp and not quite as complicated as the surface area of prisms. That lesson had 3 different kinds of prisms. This lesson just has cylinders. The lateral area for a cylinder is found by taking 2 pi r. Now you should recognize that as circumference and then times the height of the entire cylinder. And there is only one height in a cylinder, so I'm not going to use any sub C, that sort of a letter. The surface area, just like the surface area for prisms, is found by taking the lateral area plus 2 times the area of the base. So the lateral area is the circumference, 2 pi r, times the height of the cylinder. That should remind you of the curved surface from prior chapters. And then we have the area of the bases, which is pi r squared. There are 2 bases, therefore we take it times 2. Now you will note that for the entire formula, we use the radius. And they're going to give you on the diagrams, they're going to give you some diameters. So we have to watch out for that. Let's look at example 1. On example 1, first of all, you have to understand that sometimes you're going to be asked to find the lateral area, and sometimes you're going to be asked to find the surface area. You might be asked to find both. I recommend that you go ahead and do the surface area first, and then just like with prisms, use that left addend whenever you want to find lateral area. So if we're going to find the surface area, and you'll note that they give you a direction to go to the nearest unit, we're going to start with the formula. That's going to be 2 pi r h, that's the area of the curved surface, plus 2 pi r squared, which is the area of the base, the circular base. In this particular cylinder, they've given us the radius, so that's going to be 4, and the height of the radius is 13. So for 2 pi r squared, they're going to give you 4. Now, some people will use the squared. I have a tendency to write it in there twice, 4 times 4. We do not simplify with the pi at this point. We are simply going to state it in terms of pi. 2 times 4 times 13 will give us 104 pi, plus 2 pi times 4 is going to give us 32 pi. Then we will add and get 136 pi. This is where you will now simplify. You will take your calculator, take 136 times the pi key, make sure you round off to the nearest unit, which means the ones place. We will get 427 feet squared. If they ask you for the lateral area, remember that that is that left addend, the 2 pi r h. What we do now is take the 104 pi. That's our left addend. Right here, that's what we're going to take. Okay, then we use our calculators, 104 times the pi key, to get 327 feet squared. Let's look at example 2. In example 2, they give us the radius again, so that's kind of nice. We're going to start out by finding surface area. 2 pi r h, that's your curved surface, plus 2 times the area of the circle, pi r squared. 2 times pi, radius is 3, height is 6, plus 2 pi. And again, if you want to use 3 squared, fine. I have a tendency to use 3 times 3. The surface area here is going to be 36 pi. 2 times 3 is going to give me 18 pi. Now I will add those together and get 54 pi. Use my pi key, multiply with a calculator, get 170 meters squared. Now again, if they ask you for the lateral area, remember that's just the area of the curved surface. That left addend, 2 pi r h, Again, I drop down and take that 36 pi, get that calculator, 36 times the pi key, round it off, 113 meters squared. Now in example 3, you've got to be careful. Always got to look at what you're given. And in example 3, you will notice that they actually give you the diameter. So when I'm going to put it into the formula, I have got to divide it by 2. So my radius here is really 7 inches. That is not 7 inches. My radius here is 3.5 inches. So I'm going to start with my formula again. 2 pi RH, that's my area of the curved surface, times 2 times the area of the circular base, 2 pi r squared. 2 times pi, radius is 3.5, height here is 9, plus 2 pi, and I'm going to take 3.5 times 3.5. Oops, decimal point's not too clear there. Okay. 2 times 3.5 is going to give me 7, and 7 times 9 is 63 pi. 2 times 3 is 3.5 is going to be 7 times another 3.5. Yes, use your calculator if you have to. It's 24.5 pi. Now we can add them. We will get 87.5 pi. Now get that calculator out. Take 87.5 times your pi key, round it off, 275 inches squared. Now, can you figure out what to do if you want the lateral area? Yes, we're just going to take the curved surface of 2 pi RH, and again, we use the 63 pi. Now I get the calculator. 63 times my pi key should give me 198 inches squared. Here's example 4. You'll note that it's a diameter, but at this point, hit pause and you do it. And then I will do the problem and you can see how it should turn out. How did you do? Did you come up with 1,210 meters? Did you meters squared for the surface area? And did you come up with 449 square meters for the lateral area? Now our last example is going to be a practical application of how this is used. They tell us that a gallon of paint is going to cover 350 square feet. I need to know how much paint is needed to paint the lateral area of the following cylinder. Now this is where you have to read carefully. You'll note that it does not say surface area, it says lateral area. So I don't need the whole formula, I need the lateral area formula, which is 2 pi RH. 2 pi, the radius here, they've given me diameter, so it's going to be 16, times the height of 147. Yes, you're going to need a calculator for this. 2 times 16 times 147 comes out to 4,704 pi, which is going to be approximately 14,778 square feet. Now we're not done, because yes, we found the lateral area, but note that our question doesn't say what's the lateral area, it says how much paint. Now this is what you have to do if you're going to determine how much paint you have to buy if you're going to paint a room or paint several rooms in your house, and in this case paint the outside of this particular cylindrical tank of some sort. Therefore, I need to use that information that a gallon will cover 350 square feet, and I'm going to take my 14,778 divided by 350. Yes, put it through a calculator. You're going to get 42.2, and I don't think it comes out evenly as I recall. There's a whole bunch of numbers. Now, you don't normally just pour a little bit out of a gallon and sell it. So in order to really paint that tank or that cylinder, you're going to need 43 gallons. Now you have to be careful because sometimes they actually may give you a shape that contains not just a cylinder, but perhaps a triangular, contains something on top of this. But in this particular case, we're going to be working with a cylinder. And this concludes lesson 9 4B. Please respond with bongo drums. Scouting out.